Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Chuck. Give us a call here. Our phone tutors are waiting for your calls if you have any math questions. Here in Bakersfield at 636-4357. San Luis Obispo and the outlying areas, you can call toll-free at 1-866-636-6284. You can email us questions at dothemath@kern.org. You can watch the show live online at dothemathonline.net. And look for us on social media. We're on Facebook, Instagram, Twitter, and YouTube.
All right, a couple of things. We just had a parent phone in a little while ago, wanted to know how the program worked if you don't have cable. So that's exactly why we're online now for a lot of students that do not have access to Bright House cable. A beautiful day out today.
Wasn't it though?
I
Yeah.
think it was getting a lot warmer out this afternoon.
I heard it was supposed to be 75. My students were complaining that it was so cold this morning. They bundled up and then
Hot in the afternoon, hot, right?
Yeah.
In the 70s. But anyway, another place where it is beautiful almost every single day on the Central Coast.
Yes.
Pretty much if you go anywhere over
Sure,
there. But
yeah.
if you're in San Luis Obispo County,
oh yes.
even nicer, because all you have to do is phone in. We do your math problem live on air, and you automatically win yourself free ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. Makes everything a little better over there,
yes.
doesn't it? Some free ice cream. Final day, final hour
Right.
of the 5th grade call-in contest. We had 3 schools.
Good competition, right?
Right. I mean,
Yes.
everybody was within, I think, 2 calls yesterday.
Really?
Between 3 different schools. And in one of the schools, there were 2 classrooms that are
Competing against
each other. So that is going to be interesting to see if one of those classrooms from that school does take over the lead. But you've got a little bit over an hour. So that contest will go until 5:30. And as in the past, it has gone right till 5:30 some of these times. Anyway, we do have phone tutors available until 5:30, but first, let's take a look at today's Math in the News. You carry coins around a lot anymore?
Yeah, I carry a few.
Yeah, I
Some
never
change.
carry coins.
Really?
I mean, if I get coins back when I'm someplace, if I'm in the car or I'm going to the car, it goes in the car.
Right. My
Otherwise,
brother's,
at the house, it goes into a bucket and that's it. But
I always have some kind of change. in my
always.
pocket.
What do you got out of you right now?
I don't
So
have
I'm throwing
any,
you. Oh, see that? You
I
any
don't
right
have
now.
anything because we have a Kiss the Pig fundraiser.
Oh, that's
at
right. You
school,
were telling us about
and
this
so
yesterday.
I gave all my change.
So this is
to
something
vote.
new at West High, the Ag.
We have an ag department at West High, an FFA now.
Okay.
It's been
And
the last few
explain a
years.
little bit about the Kiss the Pig thing.
If
I donate, do you have to kiss the pig?
It's no.
No, okay.
It's a fundraiser for FFA, and they have 4 teams with teachers, administrators, staff people, and the students and teachers can vote on whoever they want.
By putting the money into...
Yes, and the winner or loser, I guess you could say, has to kiss a pig.
And where'd you drop your coins?
I dropped it in the team that had our principal on it. We have one of our math teachers in one of the other teams, but we figured if someone's going to kiss a pig to represent the school, it should be our principal, Mrs. Bernardin. So.
And the principal's all good with this.
Absolutely, yeah.
Right.
We have our principal, dean, our assistant principals are there, several of the teachers.
Well, I saw an article on coins and the names and where they came from. So I figured we'd just take a little look at this. Among the forms of currency to make up the U.S. monetary system, was the copper cent and the half cent. First minted in 1793. Besides being called by that name, the cent also retained the name penny, borrowed from the name for Britain's penny, which previously had been commonly circulated in the country. As for the British penny, it got its name from Old English penning. All right, so that's where the name penny comes from. The term nickel has not always been used for the United States 5-cent coin. The half dime, spelled D-I-S-M-E, is what it was originally referred to, wasn't made of nickel. Like the 10-cent coin, the half dime was made of silver and weighed exactly half of the dime's weight. Until 1883, after intense lobbying efforts by industrialists, that the nickel alloy caught on, replacing the half dime and becoming widely circulated as the nickel, named after the metal by which it was made. Hence, half the value, therefore called nickel.
Because at one time, the value of the coin was actually the value of what it was made of.
Right.
It used to be $20 gold pieces, and dimes used to be made out of silver and
Well, there were pennies also.
pennies, yeah.
Right. The dime derives from the Latin word decimus, which means 1/10. The term dime, remember spelled with an S, was used by the French to indicate a monetary value of tenth. Eventually, the S was dropped. There, now we have dime. Following suit with the dime, the quarter, which was first produced by the mint in 1796, received its name simply the worth of it, a quarter of a dollar.
Right.
So those are the coins and their names.
I'm curious why they came up with a 25-cent piece instead of a dime and a half a dime,
then
a dime and two dimes.
right,
it would have
a
been
20-cent
and
piece,
five
and make it a
20-cent
fifth.
pieces would have been, yeah, that would have been
Well,
interesting.
then there's the thing about the pieces of 8.
Right.
Right, so we'll stop there.
2 bits,
And
4
move,
bits,
right.
6
So
bits.
there's a lot of
right.
these things. So obviously we need to now tie this into a little bit more math.
Yes.
Making change. When I was growing up, and if you were working at a store and somebody gave you money, you had to give them change, you had to know what you were giving them back
Right.
before it told you on the screen. Okay? So we have a problem here. Giuseppe bought 4 packs of baseball cards for $1.96 a piece and a ball for $5.03 with a $20 bill. We need to know how much Giuseppe gets back. So we're going to multiply the 4 by $1.96 because we have 4 packs of cards, $1.96 for 1. So we multiply that, we get a total of $7.84. Add the $5.03 to the $7.84 for a total of $12.87 paid. Subtract the $12.87 paid, you'll get $7.13 back. There are a lot of students, I think, that get employed for the first time that I think are dependent on the register being correct every time and saying this is what you'll get back.
Right.
And there are times where, let's say the bill was, but I will make it where I'll give them like 2001
Right.
so that you're
Yeah, give 'em
eliminating some of the other change that you're getting back.
Like if I don't want a lot of $1 bills, I'll give them something so I can get a $5 bill back.
Right.
That's right. The other thing is a lot of times, the register will always do the subtraction to get the change, but a lot of times when you're working change and you don't have register, you won't actually do the subtraction to make change for.
You'll add up.
Yeah, you'll take $12.87 and give them 3 cents to make 90, a dime to make $13, and 14.15, and then a 5 to make. And so you give it back and you add back up to the $20 without actually figuring out how much you're giving them back.
Right.
You just give it back up to $20.
There are a lot of different ways to do that, and going back or counting up.
Right.
Either way. So that is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available until 5:30. Don't forget, if you're calling from San Luis Obispo, as well as outlying areas of Kern County, that phone number is toll free at 1-866-636-6284. We have 2 very special guests in studio, and I was going to have you do a math problem, but you cannot do a math problem right now because we've got something on the board already. So what we're going to do is, right now, come on in. I know I told you we were going to kind of sneak you on there in just a little bit. But coming in the studio right now, we've got Andrea. How are you today?
I'm great. How are you, Michael?
I'm wonderful. You are with the Kern Dance Alliance?
Correct, Kern Dance Alliance.
And what's your role with this?
Sure. So I'm the president and the co-founder of Kern Dance Alliance.
So you are the head.
I'm the head, but there's 11
okay.
other board members, and we collectively share the work.
There you go.
Yeah.
And, okay, so Kern Dance Alliance, what do you guys do?
Sure.
Because there are students going, all right, well, you're Dance Alliance, but what goes on?
Well, why don't I start with what we don't do? So we're not a dance school, we're not a dance company, we don't train dancers, and we don't have dance teachers. While a number of our board members are dance teachers, we don't actually train dancers via Kern Dance Alliance. Instead, what we do is we're a nonprofit dance advocacy organization. So we support roughly 50 different dance organizations throughout Kern County, reaching out to Edwards Air Force Base, Ridgecrest, Shafter, Taft, Mojave. We're everywhere, and we want to support all of the different dance organizations with not only monetary resources, but also with literature and history and master classes. And we basically help dance organizations that need help doing other things because they're so busy already doing so much already. But on top of that, we also work as a conduit in which we connect the dance community with the greater Kern County community.
Got it. And how long has the Dance Alliance been around?
We just launched 9 months ago.
Okay,
We're
so
a baby.
this is brand spanking new.
We are new,
All right. And I know that you've got a program that is getting underway quite soon.
Sure.
Can you talk a little bit about that?
Sure. So Shine for Girls. We're really excited about Shine for Girls. Shine for Girls is a program that combines math and dance to teach 6th to 8th grade girls math competency based upon the Common Core.
Because I'm telling my students that are 6th to 8th grade about this, and they're like, well, what exactly are we going to be doing? I go, do the math on this day,
Absolutely.
and Andrea will be there, and then you can always go to the website and find out more. But explain a little bit more about that.
Right. So Shine for Girls was actually started by an MIT graduate who was frustrated that she was the only girl in all of her advanced mathematics classes. She was the only girl on her math teams. And traditionally speaking, she is one of the very few women in STEM careers today. And she thought there's got to be a better way to get girls not only inspired to be more interested in math, but also to hopefully pursue a STEM career in their future. So Kern, the MIT graduate, was also a dancer. And so she worked to find a way to combine math and dance to inspire girls to become better mathematicians. So the program started in Boston, then it branched out to Washington, D.C., and then from there it branched to Chicago. And Bakersfield, Kern County, is the next branch to have this program.
Only 4 in the country.
Only 4. We competed with 20 other states.
Well, I was going to say, because it doesn't automatically just come here.
No, no. Kern Dance Alliance had to really undergo a very competitive grant process. So we applied and we got word early this fall that we were chosen as one of the branches. And so we're not only the first California city, but the first city on the West Coast to have this program.
Right.
And it's nationally acclaimed. The people that are associated with this program are female executives at Google, Microsoft, Cisco. So the girls that are associated with this program are immediately associated with these women in the STEM network.
Okay, now I know that you guys are going to apply some math to what you're doing.
Right.
And I know that you've got something up on the board. So why don't you explain to us a little bit about what you've got up there?
Sure. So what I have on the board is actually just more about how dancers in general use math. So the moment that we walk into the dance studio, we're immediately using math by listening to our music, right? So we have a variety of different time signatures that we often use. Is it okay if I go over to the board?
Yeah, exactly.
Okay, all right. So these are regular time signatures that we often use. A 2-4, 1 2 2 2 3 2 4 2 5 2. A 3-4, yeah. A 3-4, which we know is a waltz. 1 2 3 2 2 3 3 2 3 4 2 3. A 4-4, which is one of the most traditional we hear in pop music today. 1 2 3 4 2 2 3 4. And then our 6-8. This is generally used for faster movements like jumps and turns. 1 2 3 4 5 6 2 2 3 4 5 6 3 2 3 4 5 6. It's generally very quick and fast. So as a dancer or maybe even a choreographer, I'm going to first identify my time signature. Which one am I going to use? And say I find a piece of music, it's in my 3-4 time signature. It's very round, it's a waltz, it's a 3-4. I listen to my music, it's 2.5 minutes long, and then I figure out how many bars of 3-4s are within that 2.5 minutes of music. So I literally start listening to music and I count 1 2 3 2 2 3 3 2 3 4 2 3 5 2 3 6 2 3 7 2 3 8 2 3, all the way through 64.
Okay.
And with each of those measures, I am now applying movement. So I now have either 64 movements, 24 movements, depending upon how long or sustained the movements are or how quick the movements go. So I'm constantly counting, not only as a dancer, but as a choreographer, movement and math to create my composition.
All right.
So that's kind of how dance uses math. But in terms of Shine for Girls, here's...
Now, as far as, because I think some of the students would I don't mean to put you on the spot.
No,
Are
it's
you a
okay.
dancer?
I am.
Okay.
Yes.
So if you could demonstrate a little bit. We have a lot of open space.
Sure. No.
You don't have to do all of those.
Right. No. No. You're very sweet. So, as a disclaimer, I just had a baby 5 months ago, so I'll do my best here. But let's just take the first 4 measures. It's a 3/4. I would go 1 2 3 2 2 3 3 2 3 4 2 3. It's just something like that. Right.
There you go.
Thank you. But yeah, and in addition to using geometry, of course, we're using choreography. We're thinking about spatial design of bodies on the stage and how, say, 30 dancers move across the stage without knocking right into each other. So we're constantly using spatial design and geometry to really cue in how the choreography, based upon our time signatures and our bars, work with the music.
All right. Well,
Yeah.
if you got a few more minutes, come on back over here. We're going to have right now Chuck work on a problem. And so, are you all through with what
Yes,
we've got on the
it can
board?
go away.
All right,
Okay.
good. So we can get rid of that right now. And we're going to have an equation for you to work on.
Okay.
All right. So this is going to be 2n minus 5n plus 13 plus 9n is equal to 67. And we need to solve for n.
Okay, so we go from dance to algebra. So let's.
Well, they're going to be tying all of that together soon.
You could tie it. Yeah.
All right, so we know there are no parentheses in here, so the first thing we have to do is just combine terms to simplify this expression. We know we have an equation here, so let's just work on the left side of the equation to clean this up a little bit, and then we'll do our equality steps to solve for the variable n. So to clean this up, I'm going to look for like terms, and I notice that I've got 3 terms in here that have the variable n, 1 term 13 on this side that doesn't. So I'm going to combine 2n and 5n and 9n, but I'm going to subtract and add. So if I take 2n minus 5n, I can do that. I know that's a negative 3n. I'll put that 9n right here, and then I also have the 13. So I just switch places with the 13 and the 9n, and I still have my equation. And then I can take that minus 3n plus the 9n. That's the same as 9 minus 3. 9 minus 3 is going to be 6n. So I've got 2n minus 5n and plus 9n. All together gives me 6n plus 13 equals 67. So there's my combining like terms, and now I've got my basic 2-step equation. I know that to keep this balanced, I'm going to do the same thing to both sides. I'm going to get rid of the 13 first, get rid of the 6 next, and end up with n equals, and that'll be our solution to this equation. So let's get rid of that 13. I know I'm going to undo addition by subtraction. Have to do it to both sides. The 13s cancel out to 0. And on the left side, I get 6n. On this side, I get 67 minus 13, which is going to be 54. Now I'm going to get rid of that multiplication. 6 times n equals 54. So to figure out what number n is, I'll undo that multiplication by dividing by 6. I get n all by itself on this side, and 54 divided by 6. Well, if I know my multiplication, I know that 6 times 9 is 54. So n is going to be 9 for our solution. If I wanted to, I could take that, put it back up into my original problem, check my answer to make sure that that was the solution.
And indeed that is. 9 is correct. Thank you for that. 636-4357 is the phone number. We do have phone tutors available until 5:30, but in studio with us right now, Andrea from the Kern Dance Alliance. And when Chuck was working on that equation, you were like, I've got one too.
Right here.
So why don't you go on up to the board and we'll have you work on your equation and discuss a little bit about how that will apply to what you're going to be doing with the program.
Right, so this is a typical example of how Shine for Girls will work to combine math with dance. So it's an 8-week program, and each weekend, it meets on Saturdays for 8 weeks for 2.5 hours.
Okay.
And each weekend you cover something different from pre-algebra all the way to geometry, and it's coupled with dance. So this is a basic example of how we're going to understand how this works. So we're going to have 3 x plus y equals 3x plus y plus 2y. So pretty basic algebraic equation, right? Well, the point here is x is going to represent a dance movement. Chuck, how about you give me any kind of movement?
You mean
Anything.
like a jump?
Sure, jump. X represents a jump.
And the reason he would know that well, because your son is a professional dancer
He is, yes.
in Kansas City.
He is.
Absolutely.
So
How about
we'll throw
you?
that out there also.
Well, how about Michael? How about you give me a different type of dance
How
movement?
about if a turn?
Okay, that's what we'll do. Turn. Now, we're not going to get too technical about this. Girls that are involved in Shine don't have to be dancers. They just have to be interested in maybe learning movement. So we'll just, a jump. And how about a turn? Anybody can do that, right? You don't have to be technically trained to do that. So our x represents a jump. Our y represents a turn. We have 3x plus y. X, we've got 3 jumps. A 1, a 2, a 3, followed by 1 turn, followed by 2y, 2 more turns. Now let me put that all together in terms of creating choreography. A 1, a 2, a 3, 1, 1, 2. Woo!
I was going to say, take it easy there.
And there we go. So, and my equation went away. But you get the idea. We're applying movement to variables and understanding that math is not sort of this abstract thing out in the universe. It actually can become very tangible, and utilizing kinesthetic learning, our muscle memory takes over, and we can better understand the equations versus just sitting in a lecture and trying to understand it. Muscle memory is a really cool thing. I'm sure many of you remember dances you did a long time ago, but you probably can't really remember a lecture from a college course.
Well, come on back over here. Chuck, I expect you to explain all of this to your son.
Yes.
And how they can possibly get something going in
Yeah.
Middle America in Kansas City right there.
Yes.
Now, the other programs, all based on the East Coast and Chicago, how long have they been going?
Right, so not very long. It's recently within at least the last decade. So it's a fairly new program. It's not like we're talking 1970s. Kern started the program while she was in school at MIT. So
Okay.
that just kind of talks about how brilliant she really is. She's currently now getting her 2nd master's degree at Cambridge University. So she's a smart cookie. But the programs, I believe it went Boston to Washington, DC to Chicago, and pretty abruptly because the program was just so fantastic, and they were seeing incredible success from all of the girls in the program.
All right. Well, you know what? I know there are some girls out there right now going, how can I find out some more? So let's take a look at the brochure, or the flyer that we've got right here.
Right.
This, just a little bit of general information about it, and they can go online. So where would they go online to take a little closer look at this also?
Right, they're going to want to visit www.kerndance.org/shine. Everything is there for them.
Okay, so you've got the program dates. You're going to be starting up in April all the way through basically the end of school.
Right.
Saturdays only.
Saturdays for 2.5 hours for 8 weeks. But the most important part about this process is the girls have to apply to be part of the program. And Kern Dance Alliance does not accept the applications. It's actually the National Shine team that accepts the applications and allows the girls into the program. Applications open March 1st.
And how intensive is that application? Like if somebody went on, I mean, what kinds of things are they looking
Right,
for?
so they're going to speak about their general level in math. Where are they? What are some of their problem areas in math?
Okay.
How interested are they in learning movement and being involved in a program that's for all girls, that's really interested in not only learning about math, but also encouraging their confidence level and increasing their teamwork skills, not to mention, STEM careers, hopefully in the future.
Well, that's the goal.
Yes, absolutely, getting more women into STEM careers.
All right, perfect. Well, you know what? Why don't you give that website one more time where they can go?
No problem. www.kerndance.org/shine.
All right, there you go. And I know that the information, these flyers will be out at a lot of schools.
They are.
I know they're in some right now, but they're going to be out to even more.
Yes, they'll be
rather
out to
soon.
lots of schools. There will be a piece coming out in the Bakersfield Californian soon. We're going to be on all the news stations. We're going to be on the radio. We're going to be
And
everywhere.
you know what? It's great that
Yeah.
you kicked it off with the right
I
way,
am
with the Do
so
the Math
pleased.
program.
No, thank
well,
you.
because the
Yeah.
math and the dance together. I mean, when I met
Who
you a
would've
couple
thought?
months ago and we were talking about it, it was like, this is just a natural fit. We need to get you on and start talking about this.
I'm so honored, and thank you for having me. Kern Dance Alliance is very social. You can follow us on Twitter, Instagram, and Facebook, and all of our information is there about Shine and all the other work that we do.
All right, well, you know what? We'll check you guys out on Facebook because you're on Facebook right now for
I-
Do the Math.
I am.
as we speak. All right. 636-4357 is the phone number. We have phone tutors here until 5:30. Right now, we'll go to the phones. Student from Noble. Tony, how are you? Hello, Tony.
Yes, hi.
Hi. What grade are you in?
Fifth.
Excellent, because it is the final day of the 5th grade contest.
Good.
Let me ask you, because I know there are 2 classrooms at Noble that are battling this out. What class are you in?
Mr. Knox.
All right. As soon as you're ready, Tony, let's hear that math problem.
Okay.
Okay, go ahead.
It's 5/9.
5/9. 5/9.
Yes. Divided by 10, 2/10.
Divided by 2/10. Okay, so that's the problem. 5/9 divided by 2/10. So they want you to do this division problem and simplify your answer, correct?
Yeah.
Okay. All right, so the first question is, what do we have to do when we divide by a fraction? We spent the last couple of days talking about this. I know Marty has gone over dividing by fractions, but what is it that we have to do to change this problem so we can do the dividing by fractions? Do you remember?
I think we multiply straight across.
So if it was a multiplication problem, we would multiply the 5 times 2 and the 9 times 10. But we've got this division problem here, don't we? So the question is, how do we change this division problem into a multiplication problem?
Yes.
What's that first step that we're going to do? All right, so there's probably...
you keep the 5/9.
Keep the 5/9, right? What do we do with that 2/10?
And you switch the 2/10.
Yeah, so we're going to change it. You said switch it, right? So what are we going to do? We're going to take the 2/10 and write it as what fraction?
Yeah, it's going to be 2. It's going to be 10 half. 2, 10,
Right.
2.
So what do we call that when we take a fraction and turn it over? Do you remember what that's called?
Improper fraction.
Well, it is now an improper fraction, but what do we call a fraction when we turn it over? We're now working with the reciprocal, aren't we?
Yes.
So some teachers will say, divide by a fraction by multiplying by the reciprocal. Or like you said, you're going to keep the 5/9 and it stays the same. We're going to change the division to multiplication, and we're going to change the 2/10 to 10 halves, aren't we?
Yes.
So now we've got our multiplication problem, don't we? All right, so now you said we can multiply across and multiply across top and bottom.
Yes.
And we know we're going to reduce our answer, right?
Yes.
The question is, can we do any reducing before we multiply? Because we know we're going to do, before I multiply, I'm going to write this, 5 times 10 and 9 times 2. We can think of this problem as one big fraction, multiplying on top and bottom. Can we do any reducing with this fraction before we multiply? Well, let's look. The 5 and the 9 didn't reduce, did they? But the 10 and the 2 will reduce, won't they? So that'll make the numbers a little bit smaller when we multiply, won't
No.
they? So what goes into both 10 and 2? What goes into 10 that also divides
25 on
into...
top.
Well, we're going to... You got 25 because that's going to be 5 times 5, isn't it? So we know that 10 can be divided by 2 and make it a 5.
Yes.
And the 2 can be divided by 2 and make it a 1. So there's your 25, isn't it? So if we reduce before we multiply, let me write that as a 25 here. 25 on top, and on the bottom, instead of 9 times 2, now we have 9 times 1, don't we? And what do we do with 25/9? Since we have an improper fraction, we've got to change it to a mixed number, correct?
Yes.
So let's take that 25, and we know that 25 over 9 means 25 divided by 9, right?
Yes.
So I'm going to divide by 9 down here, and 9 goes into 25 how many times?
4 28.
Well, let's see. We know that 9 times 1 is only 9. 9 times 2 is 18. What's 9 times 3? We know that's going to be too big, isn't it?
Yes.
So let's go ahead and go 9 times 2. We know that 2 times 9 is 18, right?
Yeah.
And then to see how close we came pretty close. 25 minus 8 is 7, isn't it?
Yes.
So that's going to be 7/9 for our remainder, right? Our quotient, the 2, is our whole number, and our remainder is the numerator, and the denominator, which was a 9 to start with, stays as 9 to end with. And that should be our answer, 2 7/9. Okay, thanks for the call.
Nicely done, Tony. Am I mistaken, or do you have another problem you need to work on?
Yes.
You have one more like that? Or is it a different type of problem?
It's I think it's a same one.
Okay,
That one.
so quickly we'll work through the other one since
Okay.
he's kind of got the basic now.
All right, so give me the next problem.
It was, I think it was 2/10. Did we do that one already?
We just did the one where you had 5/9 and 2/10, I believe it was.
We had 5/9 divided by 2/10, right? So do you have a different problem than that one?
Yeah, it was 2/10.
2/10, what about 2/10? What do you want to do with that? What's the problem that we're going to work on?
Well, I think, all right, Logan, can you tell me again what that problem was on the paper?
So do you have, do you
3
have this-
tenths divided by 9/12.
So is this another problem that you had, something like this?
Yes.
You had 2/10 and now we have 3/10 and we're dividing again, right? Was this the problem? 3/10 divided by 9/12?
Yes.
Okay, so let's go ahead and do the same step, right? We know we're
Yeah.
going to, this stays the same, the first fraction. We're going to change the division to multiplication. And
Yeah.
we're going to change that 9/12 to what? 12/9, right? All right, now let's see if we can reduce. We've got 3 times 12 on top, and we've got 10 times 9 on the bottom. Does anything on top reduce with anything on the bottom? Well, let's see. We've got a 3 and a 9. Something will go into both 3 and 9, won't they? 3 goes into 3 once, 3 goes into 9 3 times, doesn't it? How about 10 and 12? What goes into both 10
Yes.
and 12? They're both even, aren't they? So we can divide both of those by 2. That'll give me a 5 down here and a
Yeah.
6 up there. And look at this. We've got a 6 and a 3. We can keep reducing. That just means our numbers when we multiply are going to be smaller when we get our answer. 3 goes into 3 once, and 3 goes into 6 2 times. And look what's left in this problem. The only thing left on top is a 1 times 2, right?
Yeah.
Well, that's pretty easy. And the only thing left on the bottom is a 5 times 1. That's pretty easy. And we did all of the reducing over here. There's no reducing there. It's not an improper fraction, is it?
Yeah.
That should be your answer. And you're done.
All right, nicely done. Do you remember we have phone tutors available until 5:30? Another tally mark for that class
Good.
over at Noble right there. The contest will end at 5:30. We'll be back with our other special guest right after this. All right, well, Liz, we're in another gallery right now. You can see that we've got a couple of pieces of work that we're going to talk about here by A.M. Rousseau.
Yes, she's an artist who works in a lot of different mediums. She does photography, she does drawing, she does paintings, and this is a collection of her works that are created only by line.
Wow.
Yeah.
So, Sarah, what do you notice about this? What would you like to find out about this piece right here?
Why, I saw right here, why do they use rag paper? Is it just something they wanted to make appealing, or?
Great question. Artists use all different materials, and a lot of the times it depends on which type of medium they're using. So here she's using an India ink pencil. So it's kind of a cross between an ink pen and a pencil. And the rag paper allows her to get the right texture. It's a little thicker and has a little bit of texture. If you look close, you'll see a little bit of texture.
Oh yeah.
Yeah, so that's just something that she decided to use, and artists use all different types of paper. There are so many different types of paper that artists can use.
Yeah.
And what else about this piece, Sarah, do you notice? I see something on the bottom and on the left-hand side. What do you notice?
I noticed that they all intersect at one point. They would all.
Many of the lines do intersect. So she starts off, her process for this piece is the beginning, the preparation is a very long process.
Yeah.
And she measures
1,
out
2,
equal
3,
distances
4,
between
5,
each
6,
and every
7,
single one of the
8,
lines that
9,
she's going to
10.
create.
Yeah.
And she draws 100 dots. So there's 100 dots on the bottom and 100 dots on top.
Wow.
Do you
And
think you could take 100 dots, make them equidistant, and then be able to do something like that?
Probably take a long time, but yeah.
it would
maybe.
take a long time. Yeah, and I thought what was interesting, the difference between the work that we already saw, Kuzana Ogg's work, and this work, is that Kuzana uses a lot of very straight lines, very geometric
Yeah.
shapes, and A.M. Rousseau's work is very organic and very flowy.
Yeah.
And really the only thing that she does that makes it that straight mathematical beginning is all of those little dots that she creates. And then she just allows her arm to just
Yeah.
make these really interesting lines.
When you look at that, Sarah, what comes to mind? What do you think of when you see that?
Think of hair, a rainbow.
Yeah, yeah.
Flowing hair, something
Yeah.
I used to have a lot of. Rainbow, you can see in
Yeah.
that. And it's just nice to see that flowing, but the definite beginning and end right there also.
And I think that's what really makes it interesting. I think if it was just lines going all over the place, it would be interesting for different reasons. But having that definite end and beginning, it really makes these pieces make you stop and think.
Yeah.
Well, let's take a look at the other piece that you've got right here.
So the process on this piece is the exact same. She starts with her 100 dots to begin with and her 100 dots to end with, and then she draws lines. This one's a little more tangled than the other one, isn't it?
Yeah, more knotted kind of.
Yeah, yeah. But it's that same organic lines that are going
Yeah.
around. Yeah.
I like how she uses like a ruler or something to make it super straight and a bunch of different angles, and I like that. I like that a lot about it.
I wonder why. See, it looks like she had a straight line here, but then she added these, which makes an interesting
Yeah.
angle there next to the straight
Yeah.
line. I wonder why she did that.
Yeah, I know. I wonder why too.
And are all of her pieces the same size?
This series are all the same size, but her works are very large and very small, depending on what they are.
So taking a little artistic movements, but always incorporating math into it. So what is some of the math that you see in this part?
Angles,
Angles,
lines,
lines. And how did she start? What did she have to do first? She had to put 100,
oh yeah, I had to put 100 dots and
right? So those points, you have to have
Yeah.
a point to start from. Anything else that you notice?
I did notice that right here it's kind of straight like the last one we saw, and up here she added it and it's so more tangled than the last one we saw.
All right, well, you know what?
Yeah.
What else can you tell us, Liz?
These lines are a little thinner, aren't they? And that's something
Yeah.
that I like as well, is that variety of her lines. Is these lines are real thin, and then they'll get really thick up here, and then maybe they'll
Yeah.
end really thin.
All right, well, you know what? Some great pieces of art that you've got here, especially tying it into some mathematics. Sarah, thank you for coming down to visit with us this afternoon. Liz, a great exhibit that you've got on right now.
Thank you.
And how often are exhibits going through the Museum of Art?
We have about 3 different exhibitions per year, and so this exhibition will close out in April, and we'll start a new one, and there will be another one in the fall, and just keeps moving on.
All right, well, you know what? Maybe we'll stop by again and see what other math we can find in art.
Okay.
All right, nicely done. Liz, thank you very much.
Thank you. Thank you very
Nice
much.
meeting you.
Nice meeting you.
All right, let's go see what other art we can find. You ready?
Okay.
All right, let's go. all about the arts today, because with the dance with ANDREA and the Kern Dance Alliance, and then the feature that we had right there with young Sarah at the Bakersfield Museum of Art, and you, young lady, if I'm not mistaken, have a field trip coming up where you're going to the LA County Museum of Art.
That is correct.
All
I am
right.
going to LACMA.
That's right. Well, you know what? Let's find out who you are and why you're here.
I am Katrina Weininger, and I am here because you offered to let the GATE students come on.
That's right. And where do you go to school and what grade are you in?
I go to Hart Elementary, and I'm in 5th grade.
5th grade going well?
Yes, it's very easy.
It's very easy? Good. I'm glad to hear that. So we'll make things even tougher for you in 6th grade when you get there.
Aw.
Oh, come on. You'll be all ready for that. What kinds of things are you working on right now in math? Because you said that the last student that phoned in with the dividing fractions,
Yeah.
you were doing that last week, right?
Yeah, I'm kind of doing something like that this week, too.
Okay, so the same kind of thing?
Yeah.
All right. Well, you know what? Since it's going pretty easy for you, why don't you go to the board and we'll get a little something ready for you.
Okay.
All right? We aren't going to do anything with fractions.
Oh, I know, darn, huh?
So Mary Lou, draw a rectangle up there if you would be so kind.
All right, let's get a rectangle drawn.
Katrina, I'm going to let you pick the number. So give me one number. I don't care what number it is. Not 1, not 0.
5.
All right, so let's make the width 5.
Okay.
And I need a number larger than 5, and it can be as large as you want.
20.
Very good.
Something to do with
And would you like meters, kilometers, millimeters? What would you like?
centimeters.
Centimeters. Very nice. Since we were speaking of centi and things earlier. All right. So Mary Lou, what I'd like you to do is, and I know, Katrina, you probably have done this, but I would like you to work on the perimeter and area of that rectangle first.
You ready?
Yes.
Okay, do you know what the definition of perimeter is?
It is the outside. It is the outside, and
Outside distance?
yeah, outside distance. I don't know how to place that exactly.
There you go, it's the outside distance, right?
Yes.
So if this was like your playground, it's gonna be, if you started here and you were gonna run,
Yes.
it's the perimeter running all the way around it, right?
Yes.
Okay, so we need to add up all the sides, don't we?
Yes.
So if this is 20 centimeters, what is this?
20.
Why don't you put that up there for me? And if this is 5 centimeters, this is also,
5.
okay. So let's solve. If we know our perimeter is the distance completely around it, you want to add those numbers all up for us?
Yes. 20 plus 20 is 40. 5 plus 5 is 10. So 40 plus 10 it
Oh, watch it. Yeah, eraser comes if you do that.
50 equals 50.
Yep, okay, go ahead and write 50 there. 50 what though?
cm.
Right, 50 centimeters, right? So that's the perimeter. Again, the perimeter is the distance around the object, right?
Yes.
But we also have to find the area, which we're going to leave it as an A, okay? Now the area is different, isn't it?
Yes.
It's not the perimeter around it, it's everything
Inside.
inside. And we call it squared units or units squared because it's like, how many little 1 by 1 centimeter squares can we fit inside here? That's what area is all about. All right? Now, do you know how to find area? Now, with perimeter, you told me to add everything up. But what do you think we're going to have to do with area?
You multiply 20 times 5.
Right. So let's go over here and do our 20 times 5, unless obviously you can do that in your head, huh?
Probably.
All right. So tell me what you're working out here.
5 times 0 is nothing, and 5 times 2 is 10, so you put 10 right here. So 20 times 5 equals 100.
There you go. So our area here is 100. And again, what's that saying? That we can fit 100
Little squares.
little 1 by 1 centimeter squares inside of that.
cm squared.
Yes, cm squared. Or you could just do this, watch. what we do is, I know you're doing that so nice, we could just put like a little 2, like an exponent. Do you know what an exponent is?
Yes.
Yep, let's just put a little 2 there. There you go. So again, the difference, perimeter is running around it, and then area is how many little squares can we fit inside. And there you go.
Nicely done. Ladies, stay right there. Mary Lou, if you could do me a favor, erase the 20 times 5.
Okay.
No.
Oh, wait, this.
There you go.
Got it.
We're going to leave everything else up there.
Okay.
Now, Katrina, here's what I'd like you to do. Let's say this is 50 centimeters of fencing or whatever, okay? So you remain 50 centimeters. That's the total you have. You cannot go over that. Okay. But I want you to configure the 50 centimeters so that you get a larger area.
Okay.
How can you manipulate that rectangle to still use exactly 50 centimeters but get a larger area out of it?
So our perimeter stays 50 centimeters.
Yeah.
But we want our area larger than 100.
So if
So how can we change these numbers to do that?
well, if we wanted this to continue to be 50, we could replace the 20s with 5, since 5 now. Wait.
What do you think? Think
Because
of
the
a number.
rectangle won't look like that anymore.
No, it won't. It's going to change, isn't it?
Yes.
So what do you think is what do we need to do? Whereas these numbers still equal 50,
Yeah.
but multiplied is greater than 100. How can I change those numbers? We could play. Let's do a guess and check.
Yeah.
Okay. So if we made this 10, okay?
Yeah.
It's always good just to do a guess and check. So let's take that off and let's make this 10. If this is 10 and this is 10, that gives us 20, right?
Yeah.
So what number do I need here to get to 50 though?
You would need 15.
15? Okay. So now let's go 10 times 15. If we change this to 15, okay, I'm going to throw this over here. Change this to 15. Okay, so we add all this up, we still get 50, right?
Yeah.
Now go 10 times 15 and see what we get.
Five times 0 is nothing. 5 times 1 is 50. 1 times 0 is nothing. Wait, yeah, gotta put 2 zeros. Almost forgot. Then 1 times 1 is 1. Since 1 times 1 is itself. Plus, add this together, it's 150.
Did we get bigger than 100?
Yes.
And we just simply changed some numbers around, didn't we?
Yeah.
And that's just another way. Do you see we just did a guess and check?
Yeah.
By just changing one number here, you were able to subtract that 20, right? Because 10 and 10 was 20 from 50, to figure, hey, 30, and you divided that by 2 to get your 15 and your 15. And we're going to put that away for 10 and 10, and there you go.
Yeah, I just realized something. For this one, you added 5, and for this one, you minus 5.
Exactly.
And that's exactly what I
Very
want you to do.
good.
I want you to do that problem. Nicely done, Katrina.
Good
Come on over here for a
job.
moment. And because you were able to increase that area, do you think you could increase it even more?
Probably, because there are a lot of numbers that you could add together to make 50.
There are, and the easiest way you can do this is remember that you were making that rectangle come closer to being a square. When you can get it to be a square, that's when you will have the maximum amount of area. So just kind of remember that as you're doing this, because if you made it longer and thinner, you would have longer sides, but the area would be decreasing at the same time. So 636-4357 is the phone number. Phone tutors are here until 5:30 right now. We'll go back to the phones. Kaylee, how are you today?
Good.
And you're a student at Noble Elementary?
Uh-huh.
And what grade are you in?
Huh?
What grade are you in?
Okay.
You're in second grade? As soon as you're ready, okay, as soon as you're ready, Kaylee, let's hear the math problem that you're working on.
2 1/5 plus 1 3/4.
1 and, I heard 4 1/5 plus, what was the other, 1 and?
No, 2 1/5.
So the first one was 2 1/5?
Yes.
2 1/5 plus 1 and what fraction?
And then 1 3/4.
3/4?
Yes.
Okay. So you're going to add these two mixed numbers together, is that right? Okay, so since we're working with mixed numbers and adding, let me put the 1 3/4 down below here, okay? And I'll get rid of this right here. So here's our problem, isn't it? All right, so what do we have to do to add fractions together?
We have to check if the denominator is there.
I'm sorry, I can barely hear you, but let's work it out here off to the side, okay?
You have to check if the denominators are the same.
Got to get the denominators the same, right? We have to find the lowest common denominator, don't we? So for 5 and 4, what's the lowest common denominator? Can you tell me what the lowest common denominator for 5 and 4 is?
20.
20, right? That's the smallest number that 5 divides into and 4 divides into, doesn't it? Okay? Now, how do we get that new numerator up there?
Now you multiply them.
We're going to multiply. 5 times what is 20?
5 times what?
5 times 4. Right. So we've got to multiply the top by 4 also, don't we? Right? 5 times 4 is 20, so 1 times 4 is 4. So 1/5 is the same as 4/20, isn't it? And 4 times what is 20? Well, it's the same as up there. It's 5, isn't it?
5.
And so let's multiply it on top. And so 4 times 5 is 20. 3 times 5 is 15. So now we've got those two fractions written as equivalent fractions, right? 1/5 is 4/20. 3/4 is 15/20. Now that you have a common denominator, what is 4/20 plus 15/20?
19/20.
Well, let's see, 4 plus 15, right? 4 and 5, that's going to be 9. So that'll be 19, won't it? So we add the numerators, but the denominator, what do we do with it?
We bring it down.
Yeah, we just bring it down. We carry the denominator. So we get 19/20 for our fractions, and over here for our whole numbers, we get 2 plus 1, that's 3. And so the question then is, are we done? Can you reduce 19/20? Is there anything that will divide into both 19 and 20?
No.
No, so it looks like that's going to be our answer. Okay?
Nicely
Thanks for
done.
the call.
Great problem right there. And I don't know why. I mean, I heard second grade, but Kaylee was actually a fifth grader
Oh, good.
from Noble, one of the competing classrooms with, I
Nice.
believe it is Mr. Knox is in there right now. And while they were working on the board, you were working that problem out right here. And you did it a little differently, but you came out with 3 and 19/20 exactly, right?
Yeah.
So there's all different ways to approach these problems and solve the problems. And I know that you are working on fractions and things like that in class right now, but why don't you go to the board and we're going to discuss a little something that will be coming up towards the end of the year possibly for you. All right, so we were just talking about perimeter and area of a rectangle and how you can maximize that by getting it closer to being a square. But right now, what I'd like you to do, Mary Lou, is we're going to discuss a little bit about triangles. And Mary Lou, if you would like to discuss with Katrina the 3 different types of triangles
Yes.
that Katrina will be seeing in the very near future.
Okay, so I'm going to make that a little bit shorter. So we have these 3 different triangles. Now, if you notice on this triangle, all sides are what?
Equal.
They're equal. And this is called an equilateral triangle because you have 3 equal sides. If we go over here and look at this one, this is a little bit different. Even though it kind of looks like this, if you notice the base of the triangle is really not the same measurement as the 2 legs because the base is the bottom and then these are called your legs, okay? So I'm going to borrow this from you. So this side and this side, do you see these slashes I do?
Yes.
It's just a little clue in geometry that says, hey, those slashes mean that both of those sides are equivalent. They're equal. However, this side with the 2 slashes is not equal. So this is called an isosceles triangle. Okay, say isosceles.
Isosceles.
Okay, there's some really fun geometry jokes about isosceles, but this is where only 2 sides are equal. So we have our, what is this one called?
Equilateral.
And how many sides are equal?
All of them.
And this is a?
Isosceles.
And how many sides are equal?
2.
Just 2. Now this one, do you think any sides at all are equal there?
None of them are equal.
No, none of them. This is called a scalene. Say scalene.
Scalene.
Scalene. This is a scalene triangle, and no sides are equal. It's where all 3 are different measurements. So when you do get into geometry, which will probably be very soon, this is what you're going to be seeing. So again, what is that?
Equilateral, isosceles,
And
scalene.
a scalene. There you go. And those are the 3 different types of triangles that you will be finding out about this year.
Okay.
All right, nicely done. Katrina, come on back over here. And because you are a guest on the program, you are now an ambassador for Do the Math. You know what that means?
No.
Okay, as an ambassador, you must let everybody know that you come in contact with about Do the Math.
Okay.
You can do that?
Yes.
And I'm sure you will do it well. So, this is the official uniform for ambassadors of Do the Math program. And I know that your mom will give you permission to wear this every single day.
Okay.
Until she says, all right, now we need to clean it up a little bit and take care of it that way, all right? But you can do that for us?
Okay.
All right? You can do that? You like this one right here? We'll find one that fits you a little better. This is just one that I have back here for all of the kids right there. But every day we give away a 4-pack to go see the Bakersfield Condors for the students that phone in. So what I'd like you to do is put your hand in here and select one of these and find out who's going to see the Condors.
It is KAILEY from Noble Elementary.
There you go, the young lady that just phoned in right now. So congratulations, KAILEY. You're going to see the Condors. Do remember we have phone tutors available until 5:30. This is the final 30 minutes of the 5th grade call-in contest. We have 3 schools vying for that spot, and we have 1 school with 2 different classrooms going for the lead. And there are about 30 minutes left on that. Phone tutors are available until 5:30. Don't forget, outlying areas of Kern County as well as San Luis Obispo. That phone number is toll free at 1-866-636-6284. Did you know that we're online?
Yes.
So you know what? You can go to dothemathonline.net, and you are now Facebook and YouTube famous.
Yay!
There you go. So you can always check out our page and check out what Katrina's been up to. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, California Resources Corporation, Kern County Water Agency, Southern California Edison, Kern Schools Federal Credit Union, and Panama Buena Vista Union School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.